Today, let us start with chapter motion in a straight line. First is basic definitions. First, position. Position is nothing but location. It can be positive or negative. Then distance. Distance is a scalar quantity where distance is nothing but the path covered, where it is always positive. Displacement. It is final position minus initial position, which is a vector quantity. It may be negative or positive. It is smallest distance covered in is displacement. It can be positive or negative. Both the distance and displacement have unit meter, where motion is called uniform motion if equal displacement occurs in equal time interval. Here distance covered is always greater than or equal to displacement. If displacement is 0, distance may not be 0. Now example sums. First is, here you can see, first body I is moving towards the east for 10 meters. Then it turned into south for 10 minutes 10 meter. Now find the distance covered and displacement of the body. Distance is nothing but 10 plus 10 20 meter, whereas displacement is shortest distance, that is, here we can see from I to F. If we can take Pythagoras theorem, like 10 square plus 10 square under root equal to under root 200, or we can write 10 power root 2. Then second, here you can see the given the body resolves one complete round. Now find the distance and displacement of body. Here R is given, I is there. Here from here to here one round, again it comes back, so displacement will be 0, where distance will be 2 pi r. The next one, given is half semicircle or half circle. Now find the distance and displacement. Distance equal to 2 pi r by 2 equal to pi r. Then displacement is 2r. Now speed. Speed is equivalent to instantaneous speed. The rate of change of time is speed. It is scalar quantity, meter per second unit. Magnitude of velocity is speed. Speed is always positive, and positive and negative signs show direction. Speed is 0, velocity is 0, but speed is constant. Velocity need not to be constant. For example, uniform circular motion. Then velocity is almost equivalent to instantaneous velocity. The rate of change of position is velocity. Velocity, it is vector quantity and unit is meter per second. Velocity can be positive or negative, where positive and negative signs show the direction, not the value. Velocity is 0, speed is 0. Velocity is constant, speed has not to be constant. Here average speed equal to total time by total distance by time, scalar, meter per second. Then average velocity, total displacement by total time, vector, meter per second. Now here you can see the average speed and average velocity. If average velocity is 0, it does not mean the average speed is 0. The magnitude of average speed need not to be equal to the magnitude of average velocity, and vice versa. In a complete circular motion, one round, average velocity equal to 0 and average speed is not equal to 0. Now example problems. Here you can see the given I to F, the line. Now V1 and V2 are there, and T1 and T2. Now find the average speed and velocity. Here average speed equal to V1 T1 plus V2 T2 by T1 plus T2, where average total displacement is V1 T1 plus V2 T2 by T1 plus T2. Both are same because both move in the same direction, and acceleration is constant. Then here the body is having two equal time interval, but velocity is different. Here you can see. Then we can use distance, average speed as V1 plus V2 by 2. Then average velocity as V1 plus V2 by 2. Now for given distance, S1 body has velocity V1, for S2 it has V2. Find the average speed. Then if we give if it is given like this, then we'll use S1 plus S2 by S1 by V1 plus S2 by V2 for both average speed and velocity if acceleration is constant. Here other situation is given two equal distances and velocity are different, so average speed equal to 2v1 v2 by v1 plus v2. Then average velocity equal to 0 because displacement is 0. Now for example, one question here: boys goes to school at v1 equal to 60 and comes back at v2 equal to 30. Here you can see the situation. So here we'll use average speed equal to 2v1 v2 by v1 plus v2 equal to, we'll get 40. Then second question, given equal to, here you can see in the straight line, distance is in two equal distances. The time, the first velocity is 60 kilometer, and in second half, here you can see in second half distance, according to time, in 2 times. In first t, it is velocity is 20, and second t is 40. So first we'll take the time. So we'll get v2 equal to, v1 equal to 60. Now v2 we have to calculate. v2 equal to 20 plus 40 by 2 equal to 30 kilometer. Now average speed 2v1 v2 plus v2 by v1 plus v2 will get 40 kilometers. Now acceleration, which is equivalent to instantaneous acceleration. Acceleration is rate of change of velocity. It's a vector quantity. Unit is meter per second square. Acceleration can be positive or negative. Negative acceleration showing the direction but not its value. Now if acceleration and velocity have same sign, then speed is increasing. If acceleration have opposite sign with the velocity, then the speed is decreasing. There is no definite relationship between direction of instantaneous velocity and instantaneous acceleration. Acceleration shows the deviation of change in velocity, a equal to dv by dt. If instantaneous velocity equal to 0, then acceleration need not to be 0. At the top of vertical motion, for example, here you can see at the top of vertical motion, velocity is 0 but acceleration not 0. If velocity is constant, then acceleration is 0. If speed is constant, acceleration need not to be 0. For example, uniform circular motion. It is possible in straight line motion that velocity reverting its direction but accelerating is not. For example, upward and downward motion of stone under gravity. In a straight line motion, it is possible that acceleration is reverting its direction but velocity is not. For example, moving car, first accelerated, then parking. Now in a straight line motion, it is possible that speed is increasing but acceleration is decreasing. For example, raindrops. First the speed is 0, velocity is 0, where acceleration starts with gravitational force. 2v equal to constant, where acceleration becomes 0. Now horizontal case of uniformity acceleration motion. Acceleration or instantaneous acceleration is constant, so average acceleration is equal. Now derivation of these formulas. First is v equal to u plus at. Here v equal to final speed, u initial speed, a average velocity, acceleration, t equal to time interval. Here for deriving all these equations, this is the first equation. We will discuss so many equations derivation. In all these equations, acceleration is constant. Now average acceleration, a equal to final speed minus initial speed by time, a equal to v minus u by t. So at equal to v minus u, v equal to u plus at. This formula is valid if a is constant. Do not use if a is not constant. Now derivation of second equation, that is s equal to ut plus half at square. For example, here you can see the case, the line is in a straight line motion. It starts with u and ends with final velocity v, and distance between them is s. So s equal to average speed into time. So since a equal to constant, average speed equal to u plus v by 2. So s equal to u plus v by 2 into t. V equal to u plus, here instead of v we will substitute u plus at. So we'll get s equal to u plus at by 2 into 2. Then we'll get finally 2 ut plus at square by 2. Then s equal to ut plus at square by 2. Now this is the equation, or we can write like s equal to ut plus half at square. Only valid when acceleration is constant. Now derivation of other equation, v square equal to u square plus 2h. Let us consider the same situation like u, v and s are present in a straight line motion. S equal to u plus v by 2 into t. Now here we will substitute v equal to u plus at, then and t equal to v minus u by a. Then we'll get v plus u by 2 plus into v minus u by a. Then we'll get s equal to v square minus u square by 2a. Then 2a is equal to v square minus u square. Then finally v square equal to u square plus 2s. Only valid for constant acceleration. Now derivation of distance covered in nth second, that is Sn equal to u plus a by 2 into 2 minus 1. Here you can see the situation. Dn equal to distance covered in total n seconds, where equal to un plus half am square. Here dn minus 1 is distance covered in total n minus 1 second, and here dn minus 1 equal to un minus 1 plus half am minus 1 square. Therefore Sn equal to dn minus dn1 equal to u plus a by 2 into 2n minus 1. Here the equation is given. If u equal to 0, then equal to constant. Sn 0 plus a by 2 equal to a by 2 Sn 2n minus 1. Here S1 equal to a by 2 2n. Here n value, if n value is 1, then we'll get a by 2. If n value is 2, we'll get 3a by 2. If n value is 3, we'll get 5a by 2. In the ratio of 1:3:5:7, we'll get these values. Then now numerical on distance covered in n second. Given in a straight line, the motion a equal to 2 and u equal to 0. Now find the distance covered in fifth half second. As we know, the ratio goes like 1:3:5:7:9. Here we can see they said the a equal to 2 meter and u equal to 0. Now calculate x using ut plus half at square. S equal to half into 2 into half square. We'll get s equal to 1 by 4. So here in it, then 1 by 4. 9x equal to 9 by 4 equal to 2.25 is the answer. Then Sn equal to 4 plus 9 by 2, 2n minus 1. Here you can see the situation. Then calculate the time when body stops. V equal to u plus at, u equal to 0, 0 equal to 9 minus 2t equal to t equal to 4.56. The distance covered for the return journey of the first 0.5 second is, using c equal to ut plus half at square, x equal to 0 plus half into 2 into 0.5 square equal to 0.25 meter. So the total distance covered in the fifth second is 2x. 2 into 0.5 25 equal to 0.5 meter. Vertical motion under gravity, or we can tell free fall. So here a equal to g, or acceleration equal to gravitational force, where value is 10 meter per second square, or accurately it is 9.81 meter per second square. So here mu equal to may or may not be 0 here. Now sign convention, upward motion is plus and downward we will take as minus. Here you can see the formulas according to the sign we have given. Then upward and downward motion under gravity is symmetrical. Here you can see it is going up and it is coming down, where here as it is going up it has positive values, and it is coming down it has negative values, but both are symmetrical in nature. Now let us apply one question. For example, here given h max. It always easy to apply the equation for the downward motion. So they have given upward, but it is as we know the formula, like upward and downward motion are under gravity are symmetrical. So let us take downward motion. Here we have to find h max, and we'll use formula v square equal to u square plus 2gh. Here h square 10 square equal to 0 square plus 2 into g into h max by 2. So h max equal to 10 square by g. We know 10 square equal to g equal to 10. So 10 square by 10 equal to h max equal to 10 meters. We can always summarize as if a body falls from the rest under gravity, then the distance covered in the equal time intervals is in the ratio of the 1:3:5:7:9 and so on. Now let us discuss about graphs. Meanings of slope. Slope at the point P equal to tan theta. Here you can see, if we take a graph of y-axis and x-axis and plot a line, if we take the tangent for the curve, then we'll get theta equal to slope angle or tan theta. If slope angle is acute 0 to 90, then it is positive in nature. If slope angle is obtuse, that is 90 to 180, then it is negative. If slope angle theta increases, then the slope increases. Now here in this case we can check whether the slope increasing or decreasing. Here you can see the theta 1 is less than theta 2, so slope angle is increasing and slope is increasing. Now various information from the graph. We can see from a particular x what is the value of y of or vice versa. The slope of graph is equal to delta y by delta x equal to positive or negative slope, increases or decreases the slope. Area of graphs tells about the quantity or y-axis into quantity on x-axis. There should be supporting equation to draw a graph. General shapes. Here you can see the first y equal to x will get a straight line, y equal to 2x will get a straight line above that, then below that we'll get y equal to x by 3. Here you can see y equal to x square, then we'll get a curve like this, and oppositely we'll get curve when y equal to x power 1 by 2 or root x. Specific equations of kinematics. Here v square equal to u square plus 2x is used for vx graphs, where x equal to ut plus half at square is used for xt graphs. V equal to ut plus at is used for velocity time and acceleration time graphs. Now rules. Slope of xt graph talks about velocity speed. Slope of vt graphs gives about acceleration. Area under vt graphs gives the distance or displacement. Area under at graphs gives a change in velocity. Now impossible graphs. Quantities like distance or speed should not be plotted on v axis minus negative axis, and quantities like distance covered cannot be showed decreasing in on graph, and a bold line perpendicular to the time axis should be avoided. A constructed line drawn perpendicular to the time axis should not cut the graph more than once. Now velocity position graph, vx graph. V square equal to u square plus 2x, v square equal to 2ax if u equal to 0. So a is given constant, v square is directly proportional to x, so we'll get graph as v equal to v equal to directly proportional to root x. We'll get a curve like this. Then various position position time graphs or xt graphs. Slope of xt given velocity gives velocity by speed. Now describe the motion of bodies shown. This graph A is bodies is at rest on the origin. It is moving like this here on the origin itself. Various VT graphs. Rule 1. Slope VT graphs give acceleration. Area under VT graphs give distance covered or displacement. Now here you can see how to calculate the distance or displacement for the velocity. For the distance calculation, add magnitude of area above the time axis to the below the time axis. For displacement, subtract the magnitude of area below the time axis from the magnitude of the area above the time axis. Now various acceleration time graphs, AT graphs. Rule 1. Area under AT graphs gives us change in velocity. Positive means here, negative is below, and 0 is here. Recipient velocity and acceleration have same sign. Speed is increasing, and v and a have opposite time, then speed decreases. How to shift plot? If a equal to positive, a greater than 0, then AT graphs then here a equal to 0 and a equal to negative. Here you can see the graphs. For example, let us take question. For velocity diagram shown, plot the AT and XT graphs. Here given VT graph, we have to convert it to AT and XT graph. Here 1, 2, 3. So first here you can see first is VT graph. Okay. First let us convert it into AT graph. Here we can see the given VT graph. So here the VT graph. Here the AT graph is straight line. Instead of this, we have to draw a straight line. Then we have to go back to the origin. Then we have to go to the negative side. Then we have completed AT graph of this VT graph. Then we have to complete VT graph into XT graph. Then we'll get like this. First a curve, then straight line, then again a curve. Now deriving the formulas we have derived earlier with the help of calculus. Here you can see V equal to U plus AT, slope equal to VT graph is acceleration, slope is equal to tan theta. So tan theta is basically perpendicular by base. So A equal to tan theta equal to V minus U by T. So A equal to V minus U by T. Therefore V equal to U plus AT. Now here you can see the derivation of S equal to UT plus half AT square. Area under VT graph equal to distance, then half into sum of parallel sides into perpendicular distance equal to half into U plus V into T equal to V equal to U plus AT. So here if we substitute V plus U plus AT, then we'll get S equal to UT plus half AT square. And here instead of substituting V equal to U plus AT, we'll substitute T equal to V minus U by A. Then we'll get the equation V square equal to U square plus 2as. Now indirect application of graphs. Here acceleration, here deceleration, here Vmax is present, and here rest and rest here given. So here alpha and beta, journey time is t, find out the Vmax. Calculate the total distance travel s. First draw a velocity time graph for entire journey. Here you can see the drawing. Then use V equal to U plus AT. Vmax equal to 0 plus alpha t1, that is first. Then 0 equal to Vmax minus beta into t minus t1, that is second. Vmax equal to alpha t1 plus equal to beta into t1 minus t1 equal to t1 equal to beta t by alpha plus beta. Then Vmax equal to alpha t1 equal to alpha beta t by alpha plus beta. So area under VT graph is distance, that is half into alpha beta into t into by alpha plus beta into t. Then we'll get S equal to alpha beta t square by 2 into alpha plus beta. Calculus. First is differentiation. Here dt t power n by dt equal to nt n minus 1. Here dc by dt equal to 0. Here dt square minus 2t plus 6 by dt equal to 2t minus 2 plus 0 equal to 2t minus 2. Integration of tn dt equal to tn plus 1 by n plus 1 plus c. Then integration of t power 3 dt equal to t power 3 plus 1 by 3 plus 1 plus c. Here dx by dt equal to velocity, dv by dt equal to acceleration equal to v dv by dx. Integration of a dt will give velocity. Integration of v dt equal to x or position. Then integration of here and the formula like x square, integration of x square dx, where limits x equal to 1 to 2. Then we'll get x power 3 by 3, limits 1 to 2 equal to 2 cube by 3 minus 1 cube by 3. We'll get answer equal to 8 minus 1 by 3, that is 7 by 3. By calculus method, we derive v equal to u plus at, then dv equal to dt equal to a. Here dv equal to a dt, here integration, and here the limits are there. Then a dt will get in the bracket v, then u v are limits. A is constant, so it is out of the bracket. Then t 0 to t, v minus u equal to a minus a into t minus u. So we'll get v equal to u plus at. Similarly, when we derive the formula ut plus half at square, here you can see the derivation. Then derivation of v square equal to u square plus 2s by calculus, here you can see. Then let us know about meaning of dy by dx. Here slope equal to tan theta equal to perpendicular to base equal to dy by dt. So we can say conclusion is slope is nothing but dy by dt dx. For example, here you can see Calculate the slope of graph y equal to x square at the point P 2, 4. So slope equal to dy by dx equal to 2x. Slope equal to 2 into 2 equal to 4. The geometrical method is slow and inaccurate, whereas calculus is fast and accurate. So we have completed the lesson motion in a straight line. Thank you.